So today we are going uh, to see the PYQs of differential equation. Okay, differential equation. PYQs. Okay. For class 12th. And for this, we start from very basic question. Okay, very easy or basic question, and then we gradually move towards little bit moderate to difficult question. Okay, so let me choose the question. Let me write the question for you. Right, first question is to find the general solution of the differential equation dy by dx is equals to 1 plus y square plus x square. And this question was asked in the previous board exam for 2 marks. Okay. So it is the easy and scoring one. Wait a minute. So for this, in next step, we separate the variables. Like we keep y dy with the variable of y and dx with the variable of x, like this. Dy by 1 plus y square dx of by 1 plus x square. Okay. Then now we integrate both sides. Here we integrate with respect to dy, and here in right hand side we integrate with respect to dx. So we know that the integration of 1 plus y square is tan inverse y, and integration of 1 plus x square is tan inverse x, and then integration constant, which is our required solution, and C is our integration constant. Okay, so this is our solution. Now we move to next question. I am putting the slide upside and choosing the next question. So second question, again it was asked in 3 to 4 marks in previous year. To form differential equation of the family of curves y equals to a sin x plus b, which is a sin of x plus b, and our a comma b is arbitrary constant, means it can be anything, 1 2 3 4 5 6, any constant number. Okay, and in this type of question what we do, to get the differential equation for the this differential equation, given differential equation, we always try to eliminate the values of constant like a, b by differentiating number of times, which can be able to realize after when we start differentiating with respect to x, this number, this variable y. And in different question we have to differentiate different number of times. In some question we are able to eliminate a and b in one differentiation, and some other question we are able to eliminate our constant a and b in 2 times differentiation and in some other question we are able to eliminate a and b in 3 times, and so on. Okay, so we are first differentiating with respect to x, differentiating with respect to x, both the sides. We get dy by dx equals to a of cos x plus b. Why? Because differentiation of sine x plus b is cos x plus b. Okay. Now we again differentiate with respect to x. We again differentiate with respect to x, and then we get d2 of y upon dx2 minus of a sine x plus b. Why? Because the differentiation of cos x plus b is minus sine of x plus b, and our a is constant. Now what we do next? Any idea? So the value of given y is a plus a times sine x plus b, and in earlier I told you before starting solving the question that we differentiate a number of times, like 1 times, 2 times, 3 times, so that we are able to eliminate this constant a and b, and we should write our differential equation in the terms of only y and x variable. So after derivating 2 times, we can see that a sin x plus b, and here also a sin x plus b is common. So here we put directly d2 of y d of x2 is minus y. Okay, and then we get d2 of y dx2 plus y is equals to 0, which is our required differential equation. The required differential equation. Okay, now we are moving to next question, third one. So let me choose the question. In starting we are doing just easy question, basic question, so that we feel confident about that. Okay, and then we gradually scale up. Now third question is to find particular solution of differential equation. Differential equation dy by dx equals to y times 10x, and we are also given condition y equals to n and x equals to 0. You can take a pause of 2 minutes and think how we can solve this question, and then I proceed to this with solution. Just try to think how can we solve this question, and then we proceed to the solution. Just take a 1 to 2 minutes and think of the solution. Any idea how can we solve this question? So 2 minutes is over. Now we are moving to the solution. Okay, just you listen clearly, focus on the solution, how I am doing, and then you can note later on. So we have given dy by dx equals to y into 10x. Like this is the given equation, dy by dx y times 10 of x. Again we separate the variables, writing the y with the dy and writing dx with 10x. Separation of variable. So this can be written as d of y by y into 10x into dx. Okay. Now we integrate both sides. So what is this? This is the integration of dy by y, and this integration of 1 by y with respect to dy is log of y, and integration of sec x is, what is the integration of sec 10x? It is the sec x, log sec x. The log of y is the log of sec of x plus c, and c is our integration constant. It can be anything, a, b, c, d, e, f. For our convenience, we only take c here. Okay. So can we write like this? Log of sec x plus log c. We can take any constant. This is also constant, this is also constant. The value of these two are different, but we in direct integration, in indefinite integration, we take any constant. So here we are taking log c for the convenience of our calculation and to arrive short solution. Okay, so this is log of sec x. Why? Because we know log of x plus log of y is always log of x into y. No, this is the basic thing based on logarithmic formula. And we can write log of y equals to log of y equal to log c sec x. So we cancel out log both of sides and we get y equal to c of sec of x. Okay. Now we have the given now we have given condition. The given condition is we have to find the solution when y equals to 1 and when x is equals to 0. Okay. So what we do? We just put the value of y equals to 1 here and x equals to 0 in here. We name it equation 1. Okay. So we write here putting our values and equation 1, and then we get y c of sec 0. Can you tell me the value of sec 0? Which is 1. C dot 1, 1. Value of c is what? 1. Okay. Now substituting the value of constant c equals to 1 in equation 1. So we get our required solution, and this is the final solution. So what we are learned, and the learning from this question is, whenever we are given any given value like y equals to 1, x equals to 0 in our question here, after solving or getting solution, we always eliminate this constant c or any constant that you assume in the question with the help of these values. You always, and our final solution will always look like this without constant. Okay, so this is, and now we are moving to next question. Okay, so fourth question. We are moving towards fourth question. Let me choose the question. Just wait a minute. Again, normal question, not very difficult. It is also easy. Y equals to x, y equals to e of 2x times e plus let here kx. Okay, we are taking kx, and now we have to differentiate this equation with respect to it. We have to solve this differential equation. We have to find differential equation form of dy by dx. If the question tells to find d2y by dx2, then we also then we find d2y by dx2. And if question asks us to find d3y by dx2, then we find d3y by dx2. Okay, accordingly in this question we are just keeping things quite simple, so we are just find dy by dx. Okay, and where a comma b is the constant in the given question. Okay, now differentiating both sides with respect to x. So you noted this function is what kind of, this question is what type of form, what form they are taking. They are ux type into vx type, and we know the differentiation of such thing. Okay, so we take dy by dx, we're differentiating first this, so we get 2 into e to x, a plus k into x. Now we're differentiating second component and writing other component as it is, so we get what value we get, k. So for your convenience I'm writing like this, because whenever y is written in the form of ux vx dot vx, dy by dx is always written like this, u dot x, this is the differentiation sign. Okay, vx plus vx dot u dot of x. Okay, now this can be written as, so we can take e to x, value of e to x common from both of the sides. Okay, so we get 2a plus 2 k of x plus k. Okay, this further can be written as plus plus 1 times k. This is our required final solution. Now we are moving to next question. Wait, fifth question. Just let me choose the question. Okay. To solve differential equation, to solve our differential equation, cos of dy by dx equals to a, where a is any positive constant. So we write equation like cos dy by dx equals to a, and then we write dy by dx is cos inverse a. Okay, then we can write dy is cos inverse a, which is dx. So dy is, this is the dy, this is dx, okay, and what is this? This is the whole constant, okay, because the a is constant, the value of cos inverse 1 cos inverse a is also constant. Now integrate both sides, both the sides, okay. So we get y equals to x of cos inverse a plus c. Okay, there is one thing more in the question I forgot to write. We have to find the final solution, when x is 0 and y is equals to 2 in the given condition. We have to find the solution in given condition, and we have already done the question, similar type of question in upper part like this here. So what I told in this question, we always eliminate constant with respect to given value like y1, x2, x0, and in this question we have given x equals to 0 and y is equals to 2. So we put let name it the equation 1, okay. So we put x equals to 0, y equals to 2, and our equation 1. Got it? So let's see what happens. Wait a minute. X equals to 0, y equals to 2 in equation 1. So what we get? And next step, can anyone assume or try to predict in next step how can we proceed? So in the place of y equals to we write 2. In the place of x we write 0 into cos inverse a plus c, and we know that 0 multiplied by anything is 0. So this becomes 2 equals to 0 plus c, therefore c is equals to 2. Now we put c equals to 2 in our equation number 1 to get the final solution, a solution which is free from constant c, because we have the given condition x equal to 0 and y equals to 2, and whenever we provided any condition of such type, we always eliminate constant c from our solution, and after eliminating the solution that we get is our final solution and final answer. So never forget to eliminate c in such type of question, okay. So we get our value sequence is 2. So putting this in equation 1, we get y equal to x of cos inverse a plus value of is 2, which is our final answer. This is the final answer. Now we are moving towards next question, 6th. You can take note of this, that seems important to you, okay. And I'm just looking for next question. Just give me a minute. Then I will write next question. You can take note of this, okay? And then I will write next question. Okay, now we are moving towards next question. Question number 6. To solve this question is bit moderate side, okay? To solve this question is little bit on moderate side. Differential equation. Tan inverse x minus of y d of x is equals to 1 plus x square d of y. Okay. So again we separate the variable in this question. Like the given equation is tan inverse x minus of y dy of dx 1 plus x square dy. Okay, now we do variable separation. So how can we write this equation? Can anyone guess? And this question, how can we proceed? So we write dy by dx equals to tan inverse x minus y upon 1 plus x square. Okay. This which can be further written as tan inverse x upon 1 plus x square minus y 1 plus x square dy by dx. Again this can be written, this equation can be written as dy by dx plus y 1 plus x square tan inverse x 1 plus x square. Now here lies the main thing. So can you visualize what equation can be the given equation in what form and in what form, so that can we proceed to the solution. Take a second and try to realize. So this equation in the form of dy by dx p of x y qx, and for this type of differential equation we solve a question in particular on a fixed way to get out final solution. Okay, and here our px is 1 plus x square. Let me write here our p of x is 1 plus x square in this question. It varies from question to question. And qx is tan inverse x 1 plus x square. Now we know that in this type of equation, our solution, our general solution is, our general solution takes form y into integrating factor. I am writing just a standard equation and then we start solving to get this q integrating factor dx plus c. And what is the integrating factor? Integrating factor, if is integrating factor, okay. This if is integrating factor. This is always e of exponential integration p of x dx. And in this question, what is our px? This is 1 plus x square. 1 by 1 plus x square. So we find accordingly integrating factor, which is if, that is equals to e of 1 plus x square dx. And we know the integration of 1 plus x square is e tan inverse x. Okay, so our integrating factor is this. Now we use in our next question, in this equation, name this equation b1. So putting the value of integrating factor and qx and equation 1. So putting value of integrating factor and q, which is our qx, and equation number 1. Okay, so what we get? Y, what is our integrating factor? E of tan inverse x, which can be written as, which further can be written as integration. What is the value of q? What is the q? What is our qx? Tan inverse x upon 1 plus x square. So this is tan inverse x 1 plus x square, and integrating factor is e tan inverse x and this whole d of x plus our integration of its c. Now for further to solve further this question, we make our integral simple by substituting required value in our integral. Okay, so for this purpose we assume, or let we assume t equals to tan inverse x. Okay, now we differentiate both the sets. So we know that the differentiation of tan inverse x is 1 by 1 plus x square dx. Okay, now we putting these values in our integral, this integral, let's say 2, integral 2. So putting values, of above values like t, dt, everything, and 2. Okay, so what we get? Y of e inverse x. Okay. So for this tan inverse x, we write t. Okay. Simple. And we know that 1 by 1 plus x squared dx is dt. So for this into this, can we write in the place of this? Okay. And here tan inverse x is t. So we write here t. And our integral constant. We don't put here t because there is no such integral here. Okay, we don't integrate this side in this type of question. Okay, now we integrate both the side, which is t times u of t differentiation and plus et differentiation et and this is t differentiation plus c. So we get value t et plus et plus c. Okay. Now we put value of t again in this to get our solution in terms of x. So what is our t? Tan inverse x. Okay. So this is tan inverse x e of tan inverse x e of tan inverse x plus c, which is equals to y of e raised to the power tan inverse x. Now we can take common here e tan inverse x, then we get 1 plus tan inverse x plus c. Okay, and this is equals to y times e of tan inverse x. Okay, now we divide both the side by e tan inverse x. See how? Y of e tan inverse x by e of tan inverse x equals to e of tan inverse x 1 plus tan inverse x upon e of tan inverse x plus c of tan inverse x. Okay. Now what is this? This can be cut both sides. This side also, this can be cut because these are same terms, है ना? So we cancel both the sides. So our y equals to 1 plus tan square x plus c times c of c divided by e tan inverse x is our final required solution. And in this question we don't eliminate the value of c because we are not given y or x like y0, 10, 20, है ना? Like in the above question we are given here x0, y equals 2, है ना? And in this question we are not given any such thing. Okay. So take a pause of 2 minutes and try to revisit the question. how we done and how we approach finally to the solution. Okay. Got it? After this, we move towards next question. Just try to revisit the question and then we move to our next question. So can we move to the next question? If we have analyzed this question, try to analyze how we approach in this question, how we approach and why we try to convert dy by dx in the form of py pxy equal to qx. Okay. If anyone has found in this question, you just try it 1 or 2 times again and again. You get the solution. Now the next question. We are moving to the next question. Question number 7th. Question number 7th. For the equation, in this equation, y equals to a plus bx plus c of x square dx cube and e of x4. Okay. We have to find wait a minute, let me just change. Okay, to find this question, to find d2 of y by dx of f4 for the given y. Okay, so we move to our next solution. So we have given y equals to a plus b of bx cx square dx cube and e of x4, where in this question where a comma b comma c comma d comma e is our constant. This is our constant. This is our any constant. Okay. Now differentiating with respect to x. what we get, dy by dx equals to, so this is constant and differentiation of constant is always 0 plus dx, what we get, what differentiation, what value we get, b. Here what we get, 2cx. Here what we get, 3d x2. Here what we get, 4 of e x cube. Okay, because we have to find the d4 by dx4, so we differentiate this four times. Okay, again differentiating with respect to x. Okay. Equation number 1, equation 1, what we get d2 of y by d of x2, which is equals to, so 0 is for so 0 we can neglect 0 because there is no significance for it. Now these are constant and we know differentiation of constant is 0, so we write 0 here, and differentiation of 2cx is 2c, differentiation of dx square is, it is 3 into 2 d of x, and what is the differentiation of 4dx cube, it is the 4 cross 3 e of x square. Okay. Wait a minute, this is x, this is d times x. Okay, so what we get, 2 of c 6 of xt plus 12 of e x square. Okay, now we name this equation as 2. Now again differentiating, with respect to x, equation number 2, we get d3y d of x2 dx cube, sorry, since 2c's are constant, so we get 0 because differentiation of constant is always 0. Now here 6xt and differentiation of x is 1 with respect to x, so we get 6 of d plus 12 into 2 e of x. Okay, what value we get? We get 6d 24 e of x. Now name this equation, say 3. Again differentiating because we have to find d4y and dx4. Here is this value, you have to find this. Again differentiating equation 3 with respect to x. Equation 3 with respect to x. Okay, so what we get? We get d4 of y upon dx4 again because 60 is constant, so we get 0, and differentiation of x is 24 times e, so what we get, 24e, which is the d4y by dx4. and this is our required solution. Okay, so required solution. So total we have done 6 questions, which was asked in the previous year examination, and on this similar pattern the question was asked. Got it? These are the pattern on which in previous year question was asked. Okay. Okay. This is the question we have done in the form, so the standard form, okay, by using integrating factor. Okay. Now I'm giving you a homework question. Okay, there is one homework question, 1 or 2 homework question that you have to solve. So just give me a minute. I am writing the question. I'll give you homework question. Just give me a minute. So everyone will try this homework question. Homework question. Okay. This is a homework question. Not much difficult. And this was also asked in the previous year, which is to find the particular solution of differential equation minus y square 1 plus log of x dx plus 2xy dy equals to 0. Okay, and this is in this question we have to eliminate c. Like like in previous question we eliminated c with the help of given value, and here the given values are y equals to 0, comma x equals to 1. Okay, here this is our required value. So you have to attempt this question by your own and try to try to do some brainstorming, or try to attempt 1 or 2 times. You will definitely get the solution for this question. Okay, so for today that is it.